Hello everyone. You have just finished watching an Edpuzzle video which explains how to use these properties that I've attached to this video to evaluate logarithms. Today we're going to continue with that concept, but it's going to be a little bit more abstract in the sense that you're not going to be given a value, you'll be given an expression with a variable, and you will either have to expand it, which means make it longer, or condense it, which means to make it shorter. Okay, so let me start with an example. Let's say you're given, so let's say you are given log base 5, I'm just making this up, of let's say 3x, okay? And the directions tell you here to expand. Obviously, there is nothing to evaluate because I don't have any values. We are just taking these properties from before and we are going to figure out which property we can use in order to expand this. So remember, there's only 3 properties, product, quotient, or power. So how do you know which one to use? Well, you got to look at your problem here. It says 3x. So what does 3x mean? It means 3 times x. And in which property are we using times? In the first one, product property. So apply the product property. Go ahead and see if you could do it yourself. Pause the video. All right, here we go. So what you should see is that we're going to take log base 5 of just 3. And then what we're going to do is we're going to add that. This is really bothering me. Okay. And we're going to add that to log base 5 of x. And that is your final answer, believe it or not. You are just taking this multiplication and you are changing it to be addition. Got it? All right, let's do another example. And actually, I will continue here just because I like to see my properties. So I'll just erase this. Let's do another expanding problem. I'm going to make it a little bit more difficult, of course. All right, so let's say I had log base, and I'm going to go with a 7 now, just because, of 5 x to the 3rd power, y to the 2nd power. So again, identify which properties you're using. So again, I am showing multiplication. 5 times x to the 3rd times y to the 2nd. So that's clearly product. But I'm also noticing that I have powers, right? 3rd power, 2nd power. So I'm also going to be applying my power property. All right, so here we go. Let's start with just writing product. So what does it say? Look above in that picture. It says we're going to first change those times to addition signs. And keep in mind we are writing log base 7 each time we expand. All right, so that's step 1. We applied the product property. Now, check. Now we're going to apply the power property. So let's look what it says where, notice power property. It says all you got to do is bring the power to the front of the log. And keep in mind, not to the front of the whole problem, just to the front of each individual one we expanded. And then once you do that, you're done. So let's see. Log base 7 of 5 plus, now the 3 goes in the front, log base 7 of x plus, bring that 2 to the front, log base 7 of y. And that is your final answer. We have expanded using product and power. All right, last property, let's make sure we know how to apply all 3 properties. I haven't done one with a quotient. So let me now do one with a quotient. So how do you know it's quotient? How do you know when you're using quotient? You will see a fraction. You will see a fraction. So let's say we had, and you know what, I'm going to do natural log. We haven't done any natural log. So ln, and then let's just say we had x over y squared. Okay, so again, this fraction bar tells you you're going to be applying the quotient property. And I also see a power, so that means we're going to be using the power property. Nothing is being multiplied in this problem, so clearly we're not going to use the product property. Okay, so let's expand. Let's first take care of the quotient. So we're going to say natural log ln x. And now subtraction, because if you look above at that picture, quotient property tells us that we change division to subtraction. Natural log of y squared. Great. Step 1 complete. And now just like in the previous example, we have to do power, meaning this power is going to go to the front. So natural log of x minus 2 natural log of y. And we are done. We have expanded our expression. Perfect. All right, now that is concept 1 of this video. Concept 2, we're going to be learning how to do the opposite. Now we're going to take a problem that is long and we are going to make it shorter. So we are going to go from a expanded expression to a condensed expression. So what I just showed you in the first part of the video was how to expand. Now I'm going to show you how to condense. Example 1. So let's say you had log base, let's go with a 2 of x plus log base 2 of y. And I'm going to even, well, actually, I'll just stop there. So let's start there. So I'm noticing a plus sign. So you have to ask yourself, what property, where am I showing a plus sign? If you look at the properties above, you'll notice it's product. So what you want to do is you want to take whatever your log is, okay, and notice it's the same base. The problems will always have the same base. You're going to bring that down, but you're only going to bring it down one time. So when you condense a problem, there should only be one log at the end. And now it says x plus y, so we're going to change that to be x times y. That's it. Okay, that's all you had to do in this problem. Condensing. So again, it changes from addition to multiplication. And there's only one log in the answer. All right, let's do one more. And I'm going to make it longer. So you see really the hardest it gets. So let's say we had 4 log of x plus, and notice now there's no base. When you don't see a base, remember that means it's a base of 10, it's just not written there. Okay, plus 3 log of y minus, let's say, minus, I'm running out of room. When you write this, put this all on the same line. Log of z. Okay, so 2 log z. All right, so what we're going to do is we're going to condense. So the first thing you want to do is write that word log, but only bring it down one time. And I like to just cross it out so you don't get confused. All right, the first one is showing the 4 in front, and what does that mean? That means that that's a power that goes attached to that x. So x to the 4th power. Then I'm noticing this plus sign. So plus sign means multiplication. So multiplication, you don't have to write the multiplication symbol. I'll just write it so you remember. And this 3 means it's a power of y. So y to the third power. Subtraction. What does subtraction mean? It means division. And then z squared. And that's it. That is how you condense. And again, that's really the hardest it gets. All right. Now the last part of this video will be how to evaluate using something called change of base formula. Okay, so in your online text, so now I'm going to just go to a brand new page. So this can be found on page 260, and you'll see it at the bottom of page 260. This is probably the easiest thing of the whole logarithms concept. It's called the change of base formula. All right, so I've told you in the previous videos that unless it's base 10 or base E, your calculator can't help you. So I lied to you a little bit, to be honest, because I didn't want you to just use a calculator. Actually, so let's say, sorry, I'm having a technical difficulty over here. Okay, so let's say you had something like log base, let's say 2 of 9. Okay. So the first thing you want to ask yourself is, can I solve this problem? So if we do the snail, right? 2 to the x power equals 9. Right? So is there a number that if I put it in there, it will be able, I'll be able to solve it? So 2 to the second power is 4, 2 to the third power is 8, 2 to the fourth power is 16. So if you notice there is no number, there's no integer that if I place it in there, it's going to give me 9. But I do know that 3 is going to give me 8. So I do know that this is going to be a number that's close to being 3, but it's not exactly 3. So if you get a situation like this, like I said, now you can solve it using what we call change of base formula. So here's how you apply it. You're going to write the word log of 9. And then you're going to divide that, and this is just using the calculator. And again, log means that the base is 10. So the calculator is able to do this. Over log base 10 of 2. And all you have to do is put that in your calculator, and then you'll see what the answer, you'll see it should give us a number close to 3. So let's do this together. Log of 9 is approximately 0.95. And then we're going to do log of 2 in the calculator, and that's going to be approximately 0.301. Then divide that. And my calculator is telling me the answer is approximately 3.16, which makes sense, right? Because we said it in the beginning, the answer should be close to 3. So change of base formula is taking this is where I wish we were in the classroom, because I would go more in detail with you, but I don't want to lose you. So it's just taking log of this number and dividing it by log of this number using base 10, because the calculator can solve that for us. Also, the change of base, if you look at the key concept on page 260, also says we could use natural log. So if we did it in our calculator, natural log of 9 divided by natural log of 2, you will also result in the same answer, 3.16. Okay, so that's what change of base means. You can use base 10 or you can use ln and you will get the same answer. So I want you to try one just to make sure you understood all my jibber jabber here. I'm trying my best. So I want you to try one. I'm taking it from the book. So this says log log base 4 of 7. This is number 45 on page 263. Okay, so pause the video and see if you could do it yourself. And my calculator keeps messing up on me, so that's why I'm taking so long here. Okay, so now that you have tried it, let's see how you did. So the first thing you want to do is rewrite this using the change of base, using either log or ln. I'm going to just use log. So you should have done log of 7 divided by log of 4. Log of 7 is approximately 0.85. And log of 4 is approximately 0.602. And when I divide 0.85 by 0.602, I will result in approximately 1.4. And that's your final answer. Now also, just last point about this video, always ask yourself, does this make sense? Like if we were to do the snail, right, 4 to the x power what number would give us 7? Well, we know 4 to the first power is 4, and we know 4 to the second power is 16, so it does make sense for this number to be almost exactly halfway between the 1 and 2, since this number is almost halfway between 4 and 16. Well, not quite, but you know what I'm trying to explain. All right, guys, I hope you understood it. If not, always reach out and let me know what you need help with. Have a good one.